Yeah, thank you. So my name is Frederik Braun. I'm going to give a talk about the same original policy in browsers. And yeah, let's start. So we're going to talk a bit about me. I promise not too much. Then I'm going to give a short motivation. Why does it make sense to think and talk about the same origin policy? Then I'm going to explain the same origin policy. And then I'm going to do a short evaluation and show some bypasses. And then we're going to look at other, that means better security policies. And then I'm going to conclude. Okay. I did my IT security degree last year and kind of studied the whole same origin policy browser security thing. If you want to read the whole thing, somebody asked me about this. This is the link. I work at Mozilla right now as a security engineer. I do play CDS, and if you have any questions, just ask. Not about me, but about the slides, obviously. Okay, why does it make sense to talk about the same origin policy? I'm going to explain what ambient authentication means and how severe a same origin policy bypass can actually become. Okay, let's assume we're on some evil web page and it can actually include other web pages in terms of iframes. That's not something very new. Every website can do that. And obviously, when the browser does something like that, you notice that no tab actually stands on its own, right? So the active session is always used. As you see, like my account is kind of present in the evil website, although it's the evil website. Okay, so if a website includes something, it's the browser doing the work and it always uses the session, and there's no way to make an unauthenticated request within the iframe or in an image tag for that matter. And that's what the term ambient authentication means. The browser is always kind of sending session cookies with its requests. And I mean, including these websites in an evil website is kind of okay, right? As long as the outer website, being evil, does not get any access to the content, but can just display it. And that is kind of what the same origin policy does. It says it's totally fine if you include stuff from different host names and different domains, and that's kind of what the web is all about. But you must not read what is inside. Well, and if the same origin policy goes wrong, it can go severely wrong in terms of last fall, Firefox 16 was released, and after a week it was put away from the website, and they said, basically, I'm going to quote what's highlighted here. Mozilla is aware of a security vulnerability in the current release of Firefox version 16. And further down the line, it says, Firefox 16 has been temporarily removed from the installer page. As a precaution, users can downgrade to version 15. And when version 16 was actually released, the typical security announcements were made that said, you should all use the new version because the old version has security bugs. And it was actually 14 of them. 11 of them marked as critical, 3 of them were high. But still they're saying, use the old version, 11 security bugs, instead of the new version, this one same origin policy bypass. And that's probably because a same origin policy bypass is not a security vulnerability like a memory corruption or something where you have some sort of attack probability and have to make sure that everything works and it doesn't work all the time. This is kind of like an API abuse. You just tell the API to do something that it isn't supposed to do, and it kind of gives you access to the whole machine. And that is how severe a same origin policy bypass can be. So it does make sense to look at it. So our scope, that means I'm going to talk a bit about the basics of the same origin policy, go into details about exceptions. But I actually did a whole lot of more, but I can't present it all in this condensed matter. So what I actually did was I looked at the same origin policy, the formal definitions, the implementations, the exceptions and loopholes. There are dozens, that's fun. Different policies. I analyzed a lot of previous bugs in the same origin policy and did some classification and some bug hunting. The results of that I'm going to show here. Okay, let's think about what is the same origin policy. I'm going to explain it for a bit. So Adam Barth said, an origin is often used as the scope of authority or privilege for a user, by user agents, sorry. Or Michal Zalewski said, the same origin policy is the most important mechanism we have, but it's also an imperfect one. Okay, that means the same origin policy is the foremost access control policy in the browser. And it controls how JavaScript accesses resources in the document, and it grants or denies access. It exists since 1996 when Netscape invented frames. But it has only been defined in a specification 2 years ago. That means 15 years of difference between somebody implementing something and then somebody writing up a specification how it should be. Of course, inconsistencies are likely to happen, right? It was spec'd 2011 in RC 6454, if somebody wants to know that. So what is an origin? An origin is kind of an attribute that is derived from a URL. So if you, the set of the scheme or the protocol of the URL and the host name and the port make up an origin. And you say something has the same origin or is in the same origin if all these 3 criteria match. That's kind of a simple example. You just compare the 2 URLs and then you see, okay, access is denied or granted. And of course, if you're having a URL where no port is given, the default port is used, AT for HTTP and 443 for HTTPS. Okay, so let's just, so we're on the same page, let's walk through a few examples and compare, are these following URLs in the same origin? http://www.example.com comparing to http://www.example.com/help. Okay, let's do this together. So the scheme is both HTTP. The domain name is both www.example.com. The port is not given, it's the default port. Is the same origin? This is the interactive part. I see somebody nodding, that's good. Of course it is. The next one you're going to do on your own, this is tricky, I know. Right, somebody's shaking his head. This is of course not same origin. What about this one? Somebody's nodding, somebody's shaking their head. What is this kind of URL? I mean, somebody might know, or at least most people should know, this is like what the browser displays when it shows an empty page. The URL or the pseudo URL is called about blank. So about is not really a protocol, is it? And it's kind of a pseudo protocol. So the browser does something and the protocol is not HTTP, so we might think it's not in the same origin, but it actually is because, well, you can't really compare host names and ports for a URL like that anyway. And the reason for this is basically legacy code, where people thought it might be a good idea to open a pop-up or a frame with this URL and then write something in this with JavaScript document write to just edit and make up a page on the fly depending on whatever happens. Yeah, and that is our first inconsistency, and I promise it's not the only one when it comes to the same origin policy. What about this one? Is this in the same origin as the URL given above? What do you think? Right, I see a lot of heads shaking. That's good. But it kind of is if you're using Internet Explorer because it just doesn't care about ports. Okay, when it comes to JavaScript, we have this kind of object hierarchy. Everything is in the global scope called window, or this for that matter. And it has object linked as properties to it, like in a neat graph. You have the history, which is kind of not actually accessible, except for you can go back and forth with it. You have the document and the document objects and all its nested objects within that represent the actual current website you're in. So the object tree kind of changes depending on what kind of website you're visiting. And that's kind of called the document object model, where the document is represented in objects and everything kind of has an object. And this kind of is a rough example of what we were seeing in the screenshot. We have a list of frames. One frame is eBay, one frame is Amazon. And when you think of JavaScript object hierarchy, it's basically, theoretically speaking, an object capability world, where you have objects, and just by having these objects, you have access to the methods and can call it or read the properties. And that's kind of a very good thing to deal with security-wise. But instead, the DOM code in the browser actually acts as a blacklist on top of this capability world, because inherently you actually have all these objects and could access them, but then there's some blacklist coming and saying, well, not this one, this is a different origin, not that one, this is a different origin. And kind of the blacklist says not what is same origin or what not, that is just a very easy policy, but the blacklist in terms of what kind of objects should I watch? Should I watch everything? Of course you can't just watch document, I don't know, document title, that it makes no sense, right? So when it comes to blacklist, it's always hard to keep up when new things come up. And we all know that HTML5 brings and brought a lot of new elements and APIs, and of course some of them were not actually protected by the same origin policy. So just theoretically speaking, it's already kind of broken because it's a blacklist. So the same origin policy is not a no way out policy. There are dozens of exceptions. Cookies are even older than the same origin policy, or frames for that matter. And you can restrict cookies, for example, to a path, right? You can say this cookie is only being sent when you access /admin, for example. Where that can be completely bypassed just using the same origin policy, because /admin has the same origin as /uploads. So there is no point in restricting something with cookies if the same origin policy, like the other security policy, gives you access to all of it. Then there's window location. If the window object you're having is belonging to a different window that might be in a different origin, you might think, okay, all the attributes are not really accessible. But window location is somehow being, you're somehow able to set window location even if the window belongs to a different origin. That's just one of dozens of different exceptions. Then there's a document domain. You can set the domain of the current document to something different, as in the suffix of your current domain, and opt in to be able to communicate with different host names in the same top-level domain, or in the same domain, so different subdomains, sorry. So you can somehow opt out of the same origin policy for certain cases here. Then there's Internet Explorer, which has this zone model, where some websites are not actually monitored by the same origin policy because they're in the local zone or in the intranet zone. That means the documents comes from the file system or from a local server. Then there's window.name, which is kind of a name you can give your window, and it persists across origins. That means I set window.name to something, move on to a different location, and it's still window.name because, well, it's kind of a windowed thing. But usually things should go away if you move away from the website. This one persists. Then there's CORS, which stands for Cross-Origin Resource Sharing, which is kind of like a new standard. I mean, it's a few years old, but nobody's really using it that much, where a website can state with its HTTP headers to completely opt out of the same origin policy. And then there's JSON-P, which kind of uses or abuses JavaScript inclusion as a callback mechanism to do cross-origin communication, and dozens of other methods that I can explain and ramble about if you ask me after the talk or in the questions. So that means the essence is the same origin policy is not just one security policy, it's highly inconsistent. So let's wrap it up for a bit. The same origin policy is mainly about read access. It's highly vendor specific. I mean, every browser implements something in his origin policy, JavaScript API things, and everybody, of course, does it differently. I mean, we remember it comes from 1996, the browser wars. Everybody was doing something else to be competitive and new and shiny and all that. So every vendor basically has its own kind of version of the same origin policy. We've seen that Internet Explorer is ignoring ports. And then we have this inherent clash between an object capability world and an access control world where things are kind of blacklisted. We've seen there are dozens of exceptions, and there is actually no consistent reference implementation at all. Obviously, I mean, everybody's doing their own stuff. Okay, so let's look at a few same origin policy bypasses and see how they compare to each other. This one's from 2007, and it's in Firefox. If somebody sets the current domain in JavaScript to harmless.com, nullbyte.attacker.com, then the JavaScript API basically says, I'm using UTF-16 strings. I don't care about null bytes. This is something.attacker.com. That's totally fine, assuming we are currently on attacker.com. So sorry, the scenario is you're on attacker.com and it tries to see information from harmless.com, being like your banking website, your shopping cart, whatever. And the evil attacker is doing something on the evil webpage, as usual. And he sets the domain to harmless.com, nullbyte.attacker.com. And it kind of looks like a prefix of attacker.com, so it should be kind of fine. But then in the underlying layer, when there's DNS queries happening and the whole HTTP thing, it's actually coded in C. So it uses zero-terminated ASCII strings, and the null byte just means the string ends, and harmless.com is resolved. That means instead of going to attacker.com, the other server is involved and you're kind of already bypassing the same origin policy. So you have a parsing mismatch between UTF-6 string parsing in the JavaScript world and ASCII zero-terminated string parsing in the DNS resolver and the HTTP libraries and so on. This one's basically from the principle exactly the same. This is from 2010 in Flash. And there's another parsing mismatch. When you give it a URL or gave it a URL like that, http://attacker.com @harness.com, Flash says, oh, well, yeah, this is http://attacker.com. This is kind of the current domain, right? And then it instructs the HTTP API from the browser, which is, of course, including the session cookie and all that, to use the URL. And the browser actually knows how to parse URLs and sees it's harmless.com using the username attacker.com. And again, the same origin policy is bypassed because of a parsing mismatch, because Flash has one concept of the same origin policy or how URLs look like, and the HTTP API in the browser has a different one. This is the next one. You see there's a pattern here, right? This is in Java. I found this last year, and you can actually do something similar here. So you give this jar URL, which is kind of like a weird pseudo protocol that instructs Java to get another Java archive for code. But basically, Java archives are just zip files with some metadata. But the spec says you don't really have to have the metadata in there, so they're basically just zip files. That means using this API, you can basically get any zip file from any other domain whatsoever using Java, because it just doesn't look at the inner thing of jar. It just goes ahead with it. So again, the URL handler is thinking something differently. It thinks jar is just like reloading code, like script text, content inclusion, that's fine. The HTTP API just requests the zip file, and if you look into the zip file, it's not actually Java code or whatever. It can be any kind of a zip file. And zip files is a lot these days. I mean, Office files are zip files, OpenOffice files are zip files, AutoCAD, Android packages, Chrome extensions, Firefox extensions, everything is kind of a zip file in between. As soon as you have metadata in and binary or something, you always zip it up. And again, the HTTP API doesn't really care about the whole attacker.com restriction and just includes the harmless.com thing. This has actually been recently patched by Oracle. I expected them, because they never actually followed up with me, I expect them not to fix it because they're obviously busy with more severe stuff. But yeah, they just fixed it recently. I'm still going to do a demo anyway. And the Wi-Fi is working, that's good. I think this is the wrong machine, sorry. No, it's the right one, sorry. So this is, the funny thing is, since this is an exploit in Java, it works basically in every browser. So I did test it with the ones on the right just recently. And you may now suggest which browser we use to test it, because I don't really care, it works in every one of them. Any suggestions? Sorry? Opera. I'm not sure I tested it with Opera though.
Has anybody ever tested anything else?
I think people test fuzzes in Opera. Somebody said if you test your fuzzer in Opera and Opera crashes, it means your fuzzer's working. Because Opera always crashes. Okay, that one worked. So here's the evil applet, including text. So we're on 10.0.2.2 something. And we're actually including something from here. And this is just for this test in OpenOffice document. And it's completely confidential, saying, oh hell, let's hope nobody reads it. The key is chocolate at dawn. And it's actually the same file I'm going to show you that is hosted on a different domain. Yeah, and just for fun, we can do it in Firefox as well. Wait, there it is. That's the cool thing if you bypass security things in plugins. So the good thing about bypassing things in plugins is it doesn't really matter which browser the people are, the victim is using. You can just bypass it anyway. Okay, let's talk about better security policies, because there are actually policies doing it right in the browser. First of all, content security policy. This is a kind of new security header that the website can send in the HTTP response and say which resources are allowed to be included, like resources meaning images, scripts, style sheets, and so on. And this is a whitelist approach. So that means it's kind of good because you say what's allowed and everything else is not allowed. And it can actually serve as an XSS mitigation. That means even if you have XSS vulnerabilities in your web page, and I promise you do, they might not be, people might not be able to exploit it when you're using content security policy. And how the XSS mitigation works is basically using CSP means you completely disable JavaScript being in the HTML document. You don't have any kind of on-click or something event handlers. You don't have script text containing JavaScript, but only script text pointing to a different JS file. And the header says, these JavaScript files are fine to be included, and everything else, JavaScript is just not executed, and you're kind of done with it. And the cool kids do it. That basically means it's supported in Chrome and Firefox, and that's kind of it. But there is probably something coming up in other browsers soon, because it's kind of a cool technology and it works. It isn't as easy to bypass as things that are like broken from a theoretical standpoint already. Let's look at a very simple example. You just send this header in your HTTP response, and you say the default source for resources is self. That means my own origin, for example, example.org. Images might be loaded from https static.example.org. Scripts might be loaded from staticexample.org and googleanalytics.com, and that's it. And when it comes to Google Analytics, everybody usually does it as inline JavaScript in the HTML document. Of course, you must not do it if you're using content security policy. Okay, the bad thing about content security policy, it's kind of hard to adopt. As you can imagine, you don't want to rewrite your whole web page. And I did some scraping of basically the top 25,000 web pages. And more than 96 of them is using JavaScript in the HTML document. That means inline JavaScript. And my scraping, I didn't even look at event handlers. I just looked at script text containing script and not URLs. So there's actually no easy way to safely allow JavaScript with the first version of the CSP specification. And that means people might not choose to opt in for CSP for a long time. Though I heard Twitter and Facebook are going to use it at some point. And there are proposals for a new version of the specification CSP where it might be possible to safely allow inline JavaScript without losing the cross-site scripting mitigation. Because, well, you can allow inline JavaScript with CSP 1.0, but then you're basically not doing any XSS mitigation, and there's little point in doing CSP anyway. And if you want to hear about the disadvantages with the new proposals to do inline JavaScript in a more safer way, I can talk about it later in the question part. Now let's come to something different, content inclusion in the web. There is iframe sandbox now, which is kind of supported in the most recent browsers. That means IE from 10 and onwards, and the other major things, Chrome, Firefox. And the sandboxed iframe means you display content in an iframe, and you can just display it. That's it. That means whatever is in that iframe, even if it's on the same domain as your web page, it's actually being handled as if it was in a unique origin. Unique means not the same origin with any other kind of resource that might exist. And this iframe is also not allowed to open pop-ups when you click links. It's not allowed to do scripting. It is not allowed to navigate the outer window by using like the target attribute on links, for example. It's not allowed to run plugins. Did I say that already? It's not allowed to submit forms. It's really just displaying in the iframe. So it's very, very good if you have user-generated content and you want to display it somehow on the web. You can use iframe sandbox. You can reduce the restrictions I just mentioned with certain values in the sandbox attribute, like allow pop-ups, allow scripting. But yeah, browser adoption is kind of a problem because people like old browsers. I mean, you rarely find people using IE10, I suppose, at least in businesses. So it's coming up, but it might not be adopted very soon. And when you do allow scripts, you usually shouldn't be allowed to do plugins and top navigation and all that. But I did find a bypass in Mozilla Firefox just last year. And basically, if scripting is allowed, you can navigate the top window just by doing the very typical frame busting thing and reload the same document in the outer window, which means it's not in an iframe anymore and you don't have any restrictions. The origin is not unique anymore. You are allowed to do pop-ups, forms, plugins, browser exploitation, whatever. Plugins means browser exploitation. So the thing about this is, I lost my point. So you can actually bypass the sandbox in Firefox using this, but it's either recently fixed or going to be fixed soon. Oh, what I want to say exactly is, so if you break out of the sandbox, you're in the non-unique origin again. So the good idea here is if you have user-generated content you want to host on the web, you just shouldn't host it on your domain. I mean, Google does it. You've probably seen it. It's called googleusercontent.com, and everything somebody uploads is never actually hosted on google.com, but on googleusercontent.com, which basically means that even if there's some cross-site scripting on it, it cannot affect google.com. So user content, different host name, iframe sandbox, you're completely fine. Actually, there's a CSP header thing that you can use to impose sandbox-like mechanisms on a resource without framing it in an iframe with a sandbox attribute. So there are safe versions, updates. There are safe ways to do content inclusion on the web right now. So we are coming to a conclusion. About the same origin policy. It's highly inconsistent. It's different for every vendor. No matter what browser you're using, you must expect that the same origin policy in this case is a different one than it was in the other browser. And theoretically speaking, it's a blacklist when it comes to think about which DOM elements and which APIs are to be restricted and which ones are not. And then there's plugins. So even if you think, okay, I'm just testing one browser, there's one same origin policy. Well, there's not. As soon as a plugin is loaded, you have like at least 2 same origin policies in your browser. And of course, they might disagree and parsing mismatches, bypasses. You've seen it. And last year, there was Java enabled in nearly 70% of all browsers, although only 0.2% of all websites are actually using it. That's kind of bad, and I would say, please disable Java. But in early 2013, actually a lot of Java exploits came up, and then everybody thought about click-to-play, and Java's kind of restricting itself now. So it's going to be better in terms of people not using Java in the browser. But on the upside, there are safe and well-designed security models on the horizon. So the web might actually move to something better soonish. Yeah, and the whole point about same origin policy bypasses is, as we've seen on the slide, parsing mismatches when one layer thinks something's going this way and it's actually going the other way. Future work. What is there left to be done if you want to look at the same origin policy and find bypasses? Maybe it's automation. I'm not 100% sure. Well, I do know that testing in the browser is very easy because the same origin policy bypasses are essentially HTML and JavaScript. So you can just do the try-catch thing. And whenever an exception is not caught, you probably found a bypass in your tests. And you don't have to do like crashes and failover and restarting the browser if you were doing fuzzing. You can just let the HTML document run and do the testing. Though I have to admit that my bypasses, which I found, were not actually found with automation. And by the way, there are like prototypes for doing testing in the browser with JavaScript and HTML. You don't even have to write your own test harness. I want to close with a quote. I was amused by this. Somebody on StackOverflow.com says, "This same origin policy is the dumbest thing ever. All this protection serves to do is aggravate legitimate developers trying to get JavaScript to do the simplest of tasks." I suppose he's happy I didn't mention his name. I was actually considering getting a t-shirt saying legitimate developer. And that's basically it. I gotta thank a few people, my advisors and supervisors from the university, Torsten and Mario, who's standing right there, and my friends from Fluxfingers and fellow students, and my girlfriend, and many, many smart researchers whose work I built upon because I read a dozen of smart papers. And basically you for listening. Thank you. So as I mentioned, there's the full thesis. It contains a lot of references. It's worth a read if you're interested in that. On top of that, any kind of questions? Okay. Nothing? Thanks.